Hi everyone, I'm Gabe, and a lot of people talk about reproducibility in data science and computational work generally. And I think that's a fantastic topic that is relevant both to visualizations and to, more generally to sort of model fits and statistical analyses. But I'm actually going to talk about what happens sort of after that, once you have a result that is more or less the way you want it. So you are pretty sure it's right, it's reproducible. What then? And so for a little bit of context, science doesn't happen in a vacuum. So Steve talked earlier this morning about how science doesn't happen in a vacuum in terms of people working together and bringing different types of insights into the same data. And that's not quite what I mean. Science also builds off of things that either you or other people have found before. So there's this very famous quote by Isaac Newton that he saw as far as he did, and he was able to do the work that he did because of the things that people had found before. Now, obviously, he wasn't talking about things that were done with computers, but the same type of story happens with data analyses, right? When you're approaching a set of data, unless you're the very first person to ever see that data and you're seeing it for the very first time, the first step is generally going to be, what do we already know about this data? What knowledge about the data or the relationships can I leverage when I'm furthering it with my own analysis? Now, that can be somewhat difficult given how a lot of our results are handled after their sort of initial use. Which looks a little bit something like this, right? You have a result, you have delivered it to your collaborators, maybe you've put it into a publication, and then it just sort of sits there, right? No one else really knows that you have it. You may not even remember where you put it or what you named it. It's in some directory somewhere along with a bunch of other PDFs with very similar names. And this makes it difficult to then come back 6 months to a year later and try to do something more, like build on the thing that you've already done to continue that. And that is what we're going to talk about today. Now, the other question, of course, is can you actually do it again, right? Like you may have saved a PDF of your plot, but can you actually make the plot again so that you can add a new theme or add a smoothing parameter or change the smoothing parameter or things like that, right? This is, again, is something that is not as easy as it should be in the workflow that I feel like most people generally have. It's certainly not very easy in the workflow that I have, right? I have my R scripts saved somewhere. I have my PNGs saved somewhere. If I'm lucky, they're in the same directory and there's some sort of relationship between them in terms of the file names, but who knows? Maybe I was having a bad day and I named it wrong and I'm never going to find it again. So you have this result. You want to be able to use it in the future. You want it to be able to be as sort of impactful both to yourself and even to the wider scientific community as it can be. How can you do that? So for the rest of the talk, what I'm going to present is some work that I've been doing, some research that I've been doing on some ways that we may be able to try to mitigate some of these problems. And the work specifically is embodied in this trackr framework that I've been working on. And it basically does 4 things. So the first thing that it's going to do is it's going to actually look at the results that you're making and figure things out about them that are sort of annotations that are going to be useful in the future. And we'll talk about why that's important that it's going to do that in a second. But that's sort of the core underlying feature of what it's doing. And then it's going to use those annotations, it's going to use that metadata that it's figured out about your results to organize and catalog them for you. Essentially, a database of results that it knows about is going to get built up over time as things are submitted to it. And so you don't have to remember what you called the file. You can just actually look in the database and search for this result that you know you made 6 months ago, and you should be able to find it. And that's the third point. And it provides a number of different ways of sort of modes of action for this type of search. You've got an R API for retrieving things directly. You've also You can use these types of backends to power web front ends where you can search for things in a sort of standard search index, which we'll see in a little bit. And then there also is experimental integration with RStudio, which means that you can actually incorporate finding things that you did before into your analysis process if you're working within that IDE. And there are some sort of nice things that come with that that I'll talk about a little bit at the end of the talk. And just as a final point while we're describing the framework itself, all of the things that it does are completely customizable. So I tend to, some people say I over-engineer things. I like to think that I engineer them the right amount. But basically everything that it's going to do, you have control over. You can control what type of metadata it extracts from certain types of things. You can control how it's being stored, whether other people can see it or whether it just sort of lives locally. All of these types of things are things that you can set. So now we're going to go into the first live demo where we're going to see a little bit about what I'm talking about. So suppose I have a collaborator that is not, they're a bench scientist, they're doing experiments, sort of physical experiments. They don't really use computers very much, but I'm helping them analyze their data. They may want to sort of keep up to date with what I'm doing and the project related to them, whether there are any new results and where they can get those new results, how they can look at them. And so one of the ways that you can do that, a very simple way, is to just have an RSS feed of the things that are related to them in some way, either by project or by being tagged as for them or what have you. And so here, this is just a sort of bunch of toy examples of things that I've done in R. But we can see that this is an RSS feed of various plots that I've made, and we can look through them. They're in order of most recent. We can also sort of click on them, and then we get into this. This is a front end called Blacklight, which I'll just talk to you a little bit more about in a second. I didn't develop it, we just use it. But this, here you can see we have this is a screenshot of an RMD report, and then we have a bunch of extra information about this. And this is actually only a subset of the information that's there. Now, that's all great, but for all you know, I could have just put all of those things in there myself. So what we're actually going to do is we're going to make a new result, and we're gonna refresh the RSS feed, and it's gonna pop up live. So the first thing that we're gonna do is we're gonna load the trackr package, and then we're gonna set up the backend, which uses Michael Lawrence's RSolar package to basically maintain a Solr core. Solr is a search engine technology of these results that we're making. So here we've got ggplot. We're going to change this from sepal length to petal length, just so that it's not identical to something that's in there before. And then we are going to make this plot. And then we can see this plot. There it goes. That's great. And then instead of sort of saving the plot using the R graphics device normal way, we're actually going to say record this. And this is going to be recorded by trackr. And in a second, when this finishes, it's going to pop up. Don't worry about those warnings. They're just, it's trying to normalize a path that's not there, and R complains about that sometimes. But as you can see, now at the top of our RSS feed, we have our new plot. So this is something that you can have where you just sort of give your collaborators this URL, and they can sort of watch it and see, and you can push things to it whenever you think it's ready for them to look at. And that's one way that you can sort of facilitate sort of in asynchronous collaboration, where you don't have to sort of poke at them and they don't have to poke at you. Each of you can sort of know what the state is. Now, this is an individual plot, and I think most people here are probably more likely to sort of encapsulate plots in sort of R Markdown reports that they'll then host somewhere and point people at. And as we saw, there is support for that, but we're just going to go through an example of that as well. So we have our demo.rmd. So we're going to change this. This is no longer a test. And then this plot actually isn't that great. So this is Gabe's only OK plot. And then we're going to call knit and record. So what this is going to do is this is actually going to knit our RMD file into HTML and record that we have this new result and put it into the trackr backend that we're using and all of that. So this takes a little bit of time because it's doing a bunch of stuff. First it's knitting, and then it's using our Selenium to actually control Chrome and get that screenshot. But the takeaway here is that now there are two things. So now we can see we have our fancy live thing. And the other thing to notice is that we have a record for the RMD, and we also have a record for the plot that was inside the RMD. And that's going to be relevant when we're searching for things later. So we can actually search for RMDs as a whole, because we'll talk a little bit about what actually gets indexed a bit later. But basically, you can search for the RMD and find all the things that are inside it, or you can search for the things that are inside it and then actually get back to the overarching report. So you can do that in either direction. And that's facilitated by them having these separate records here. So this is all great in terms of sort of active, ongoing collaboration, but there's also the thing that I actually talked about in the beginning, which was, so you made some plot somewhere, and you'd like to find it again because you want to send it to someone that hasn't seen it before, or someone else is working on the same data set and they just want to see what have people done with this data set before, so that they don't have to redo other people's work, so they can sort of be more efficient. So this is Blacklight. As I said, I did not develop Blacklight. This is an open source solution. I believe it came out of somewhere in Stanford, but we're using it because it's this really nice sort of image gallery that we can leverage here. So let's see. What are all the plots? Here are all the things that are related to iris. So you can see our new plot is in here. There's our new RMD and our only OK plot that we made over here. But you can see there's a bunch of other stuff too. And so you can say, well, I only really want the iris that is densities, like what's this thing about densities. And so now you have this smaller set of plots. The RMDs are gone now because none of those had anything to do with densities, and they weren't using those geoms. But you can still see that there are 3 of these here. And then you could actually say, yeah, so you could say sepal length, I think, is actually still going to give 2 of them. But it looks like, I guess that's giving all 3. Yeah, that's right. OK, so the other thing that you can do is you can search for text that's inside these RMDs, and you can find these. So the thing about an RMD is that it is a set of annotations about the results that you put inside of them. And it's obviously very specific and very informative, otherwise you probably wouldn't have written it. So we are going to index all of that and actually use it to make these results discoverable, which is this word that I'm using to combine the ability to know something exists at all and the ability to locate it and the ability to retrieve it. Right? These 3 things combine into something being discoverable. And so, yeah, we're going to index. We're also actually indexing the code, and we're extracting a bunch of things from the individual results. And I'm going to talk about that more now. So that's a little live demo. We'll have another one near the end of the talk here. OK, so discoverability. I hope I've convinced you that discoverability is a good thing to have, that you really sort of want that. So how do things become discoverable? Well, if you ask Figshare, Figshare is a result sharing service that has been around for quite a while. It's pretty popular in at least certain scientific realms. And they actually have an FAQ about this, which basically boils down to it depends on what you told us about your result. if you didn't tell us anything about your result, we're not going to be able to let anybody find it because we don't know anything about it. And so unless they know like the actual hash or the exact day that you submitted it or something, they're probably not going to be able to get their hands on it. If, however, you have given them a bunch of metadata that's sort of semantically informative about this result, then people can search for that and they can find your result, and therefore your research is discoverable. And so what this boils down to is that it's all about the annotations, right? So the annotations can take us from the situation where we're in that warehouse with a bunch of sort of unlabeled crates that you're never going to find anything in, to a situation where you know exactly where to look to find any particular type of thing, and you're able to find any particular type of thing. So if I asked you to find, you know, a Star Wars action figure, you would know which box to look at, and you would be much more likely to be able to find the actual action figure. So where do these annotations come from? Well, ideally, and this is Figshare's sort of Figshare strategy, and it's a good one. I'm not at all saying that they're wrong. Ideally, it comes from you. The analyst knows more about their result than anyone else is likely to ever understand, right? They're the ones that actually created it. They knew which questions they were asking. They know everything about the data that they're sort of exploring and analyzing. And so the ideal is that every time you make a result, you will actually annotate it with a bunch of really useful information that we can then use to make it immediately discoverable. And you actually generally get sort of close to that when you're in the sort of RMD space, where you're actually sort of writing up the results that are embedded in the report. But even then, you have to be able to find the report. And so we index the text, as I talked about earlier. But generally, even though this is the ideal, it's probably not actually super feasible to expect the analysts to do this every single time they do anything, because they have work that they need to get done, and that work usually involves making more results, not sort of writing about the results that they already have. There are exceptions to that, of course, but anytime you can make the analyst life easier by doing things for them so they don't have to do it themselves, I think that's a win. And so the question then becomes, what kinds of things can we figure out for free? What kind of metadata can the trackr framework attach without any explicit interaction or intervention by the analyst? And so trackr is actually going to look at 4 different sort of contexts to try to get some information about what you're doing. And those are the computing environment. So where are you? What software are you using? Who are you? Right? Like, what is your login name? And these types of things are generally useful in certain contexts. For example, if I come along a year later and I want to recreate your result, it's going to be very useful to know which version of R and which versions of the packages you were using, and which, what file system you were on and what files you were accessing and things like that. And so we're going to capture all of that just sort of automatically when you actually record your result into the back end of your choice. The second thing, and probably one of the 2 most important and richest sources of information, is the result itself. So objects tend to be self-describing, right? Because they have their contents in them. So you know what their contents are if you have a handle on the object. And the other part of this is Thomas talked about ggplot and how it has this really nice grammar for sort of declaring visualizations. And so that's what I sort of mean by the design of the result. Now, in a modeling context, that would be, in our parlance, the formula. So what terms are you sort of regressing against what terms and things like that. And so these are sort of the design of your model or of your visualization. And those are extremely informative, as I will talk in more depth about in a moment. Third is the code. So code is necessarily a complete description of exactly what you did, because if it wasn't, the computer would not have done it, right? The computer is only ever going to do what you tell it to do, and your code is what you told it to do. So we necessarily know everything about what you asked it to do, and therefore, in as much as a result is sort of deterministic and a product of the code you run to make it, we now understand those things about the result. And so we're going to extract quite a bit of information from the code. And then finally, the data. So you can summarize the data or name the data, and that actually will tell you quite a bit about what the result is. Are you working with the whole data set or only a subset? And if it is a subset, which subset is it? And this also sort of bleeds into the code, because the code is probably how you actually did that subset. So that information will be in there as well. But if you're talking to a database, which database did you talk to, right? Like, what version of the data are you using? Where did you retrieve it? Things like that. If those are present, those are very useful pieces of information as well. So now I'm going to go a little bit more detail in some of these sources of information. So first off, what does the code give us? I touched on this a little bit already, but the code basically is going to give us at least 3 sort of distinct classes of information and ability. The first, as I said, is the ability to know exactly what the computer did and sort of conditional on access to the data, be able to do it again. So once I get my hands on the result and the code corresponding to the result, I can actually find out whether the result is reproducible or not by trying to reproduce it. The second one, which is related but subtly but importantly different, is what was the analyst actually doing? Right? So in order to trust a result, which is necessary before it's a good idea to extend a result, we really need to understand what that result means and how it got there. And by doing that, so these are things like, what methods was the analyst applying? And the code tells us that, because those methods are applied by calling functions. And thirdly, the code is often self-describing, right? Like, functions are named the way they are for a reason. And so oftentimes, if you just look at the name of a function, you will have some idea of what it's doing. And so if you sort of take the aggregate of all of the useful names of the functions in the block of code that generated a result, you're probably going to be able to make some pretty good inferences about what that result is. Now, the other really big piece of source of information about result, and I'm going to talk in terms of plots now, but this generalizes to statistical models and things like that as well, is the design, this design that I was talking about earlier. So what does that give us? Well, it gives us quite a bit, in fact. More specifically, it gives us insight into the question that the analyst was asking. So the way that visualization typically works is an analyst has a question in their head about their data, and so they construct a visualization in order to try to answer that question. Now, we don't have a view inside the analyst's head. We may not even immediately have the data, but we do have the plot. And so that plot actually tells us what question it was answering. So if any of you guys are looking at this, we should immediately be able to tell that these are answering questions about the distribution of individual variables within this data set, because that's the only type of question that that type of plot can answer. Similarly, if you have something like this is actually asking a question about whether, this is the diamond data set, we saw it a little bit earlier as well. This is asking whether price is related to caret, but specifically it's looking for interactions. And that's what you get whenever you have these small multiples of scatter plots or whenever you have this sort of grouping by color. These are visual representations of answers to the question of whether there's an interaction term in sort of the correct model for that data. Now, I'm going to talk a little bit more specifically here about exactly what we're capturing. So this is a subset of the data. We actually capture quite a bit more than this. But for this plot that's on the left here, we know the geom type, which is point and smooth, which means that we essentially know that it's a scatter plot with a more or less regression-y fit overlaid on top of it. We know that there's no title, which means that I'm a terrible data scientist, because you should never have plots that don't have titles. We also know which variables are involved. We know the x variable, we know the y variable, we know the variable that's used to group by color, and we know the variable that's used to split the different panels. And we also have the session info and the code, and down here at the bottom, we actually know where the code that this came from lives, which RStudio project and which R script file they were being used when we generated this. And so I hope you can see that that's quite a bit of information that can be useful both for inference about the result and for locating the result if we sort of have a picture of it but don't know where it lives. And similarly, we can talk about the same type of thing for RMDs. So for RMDs, we have the chunks, which is all of the text. We all have all of the code. We have how many plots there are. We have the RMD file. We have a hash of the contents of the RMD file, which means that if you run it again with different data or after having edited it but with the same name, we'll actually be able to tell that those are different. And that's not immediately useful by itself, but if trackr is sort of feeding into other larger systems, that becomes important for tracking things like provenance. And then we have a bunch of other information, including third from the bottom there, we have the IDs of all of the results that are embedded within this report. So we have the ID of that plot within the backend, so that's how we can get back and forth. So now I'm going to just briefly do this second demo, which is the experimental RStudio integration as a sort of wrap up. So here we can see we're in RStudio, maybe we're working, and we just ran a function, and now we have this sort of, not as nice as blacklight, but we have the ability to search for things that we've done, right? So I can say, I don't like empty cars, I like iris instead, so it'll take a little bit, but then it'll pop up all of the iris plots that we have. Now, I apologize a bit for the resolution, which, as I said, is experimental, so this will be, fixed eventually, but we can scroll down here, and at the bottom, it actually has this information about where the project and the R script lived. And so we could actually sort of cut and paste this and actually open it up in RStudio and then continue to work by iterating directly on the script that actually made that plot. And that's not something that's going to be very easy to do without something like this. It doesn't have to be this exact tool, but we need our results to actually be discoverable, both to ourselves and to people in our fields in order to sort of drive science forward. And with that, I will end with an acknowledgement slide. So this work was joint with an intern that I had a couple of years ago named Sarah Moore, who did a lot of the initial work. And also Michael Lawrence is a collaborator on this project. And then a number of other people around Genentech have been really essential in giving feedback both on a manuscript on this and on the code itself. I'd like to thank PLOTCON for inviting me to come talk to you, and finally you for sticking around and listening. So with that, I will take any questions.
Great work, Gabe.
Thanks.
So could you talk a little, this is fantastic. So I'm wondering, you touched on a couple of use cases, but how do you envision this going forward in terms of different applications of use cases, let's say for scientific papers, posters, and interactive posters, that sort of thing? What do you see going forward with this sort of approach?
So the question about papers is a tricky one, right? Because typically you have a paper and that paper has embedded in it your visualizations or your sort of tables or your model that you've put in some sort of textual representation. Now, one thing that you can do is if the paper was actually generated with one of these sort of dynamic document systems, you could actually have a version of that paper registered in a system like trackr. so that it would actually know about all of its results in the same way that the sort of baby report that I had here did. Another thing that you could do is sort of have a public-facing tracker backend and then have sort of the ID keys as in the supplemental materials so that they could be linked out and you could go sort of find the record of the results that include this metadata and then the code and things like that. One thing that would be nice, which is a little trickier just because of sort of order of operations, would be to sort of actually be able to put the DOI for the paper in the metadata for the results. Now, it happens after, and editing things in a sort of system that's supposed to track history is always a little bit iffy, but that is something that would be worth investigating as well. Some way of associating these things with the actual publications once they come out would be really good.